Good day, Bayaos. Today we're going to solve a problem from the book of Thermodynamics by Eunice Engel, Chapter 10, Heat Transfer by Convection. Water at 25 degrees Celsius and a 1 atmospheric is flowing over a long flat plate with a velocity of 8 meters per second. Determine the distance from the leading edge of the plate where the flow becomes turbulent and the thickness of the boundary layer at that location. So first is we're going to determine our given, wherein our Reynolds number is equal to 5 times 10 raised to 5. The temperature is equal to 25 degrees Celsius and our velocity is equal to 8 meters per second. So going back to the problem, water is being mentioned at 25 degrees Celsius and 1 atmospheric. So if we're going to look at the property table, table A9, the water's density is equal to 997 kilogram per cubic meter and the kinematic viscosity is equal to 0.891 times 10 raised to negative 3 kilogram per meter times seconds. So we have here this equation. Reynolds number at critical point is equal to the density times the velocity infinity times the distance at the critical point over the kinematic viscosity. So since we are asked to determine the distance from the leading edge of the plate, the equation will become like this. The distance at the critical number is equal to kinematic viscosity times the Reynolds number at the critical point over the density times the volume infinity. So with this equation, we can now find the distance. Just substitute all the given values and plug it in your calculator and we will get 0.056 meter. So we're going to convert it into centimeter and we will have 5.6 centimeter. So next is we're going to determine the thickness of the boundary layer at that location. So we have here this formula. Delta at the critical point is equal to 5 times the distance over the Reynolds number of x raised to 1/2. So the thickness of the boundary layer at that location is obtained by substituting the value of x into the laminar boundary layer thickness relation. So the equation will become like this. The delta at the critical point is equal to 5 times the distance at critical point over the Reynolds number at critical point raised to 1/2. So just substitute all the given values and plug it in your calculator and we will get 0.00040 meter. So we're going to convert it into millimeter and we will get 0.4 millimeter. Therefore, the flow becomes turbulent after about 5.6 centimeter from the leading edge of the plate and the thickness of the boundary layer at that location is equal to 0.4 millimeter. So that is all for today's video. Thank you for watching.